Welcome to another deep dive. This time, we're taking a look at constructor theory.
Sounds intriguing.
You sent in some really cool stuff. A YouTube video with physicist Chiara Marletto,
Oh, yeah, I've seen her work. Fascinating stuff.
Wikipedia and the constructor theory website, and even an essay by Marletto in Eon.
Wow, a good mix.
Yeah, should give us a good overview, different perspectives.
For sure.
So I think most people know physics has had some incredible discoveries,
Absolutely.
but there are some things it just really struggles to explain.
Yeah, like what?
Well, that's where constructor theory comes in, actually.
Okay.
It approaches these problems in a completely new way.
Hmm.
Instead of predicting what will happen,
Right.
it tries to understand what's even possible at all,
Interesting.
what's possible and what's impossible in the universe.
Kind of like figuring out the rules of the game, the fundamental rules.
Yeah, I like that. The rules of the game of reality itself.
Exactly.
So how does this differ from, how we normally think about physics?
Well, traditionally, we think about physics
Mm-hmm.
as describing the world in terms of trajectories and initial conditions.
Okay.
If we know where things are and how they're moving,
Right.
then we can predict where they'll go next.
So it's all about prediction.
Yeah, pretty much. But
Uh-huh.
constructor theory says, well, maybe that's not the whole story.
Okay, so even our big theories, like quantum mechanics and relativity, groundbreaking as they are,
Absolute.
still rely on this framework of trajectories and initial conditions.
Exactly. Imagine trying to explain a car
Okay?
just by describing how its parts are moving.
You'd miss the big picture,
Exactly. You'd miss what the car is even for.
how it works as a whole.
Exactly.
Interesting. So where does constructor theory actually come in?
Well, constructor theory brings in this idea of counterfactual.
Counterfactuals.
Yeah. These are statements about what could or could not happen, which traditional physics doesn't really deal with.
That sounds a little abstract.
Yeah, it can be.
Can you give me like a real-world example?
Sure. Think about a lifeboat on a ship.
Yeah.
Its purpose is tied to the possibility of a shipwreck,
Right.
even if one never happens.
Okay.
This counterfactual that a shipwreck could happen explains why the lifeboat is even there.
Right. It has to exist just in case.
Exactly. And constructor theory says these kinds of possibilities,
Yeah.
these coulds and could nots are fundamental.
How the universe works.
Yeah, to understanding how the universe works.
So it's not just what does happen, but what could happen.
Exactly.
That's a pretty big shift.
It is a big shift, and it has some really profound implications.
Okay, like what?
Well, for example, the laws of thermodynamics.
Okay, the laws that deal with energy.
Right, energy and how it changes.
Right.
They're actually based on counterfactuals.
Really?
Yeah. Think about the idea of a perpetual motion machine.
Something that creates energy from nothing.
Exactly.
Yeah.
That's impossible.
Right, because of the laws of thermodynamics.
Precisely. And that impossibility, it dictates how energy flows in the universe.
So even though a perpetual motion machine doesn't exist,
Right.
the fact that it can't exist shapes our reality.
That's the point. Or think about the Heisenberg uncertainty principle in quantum mechanics.
Okay, I vaguely remember that from school.
Yeah, it basically says you can't measure certain things perfectly at the same time.
Like what kinds of things?
Like a particle's position and its momentum.
Okay.
You can't know both with perfect accuracy. And these impossibilities,
Yeah.
they're not just like random quirks. They're fundamental like constraints.
On how the universe behaves.
Exactly.
Wow, that's pretty mind-blowing.
It is.
So constructor theory is saying these counterfactuals, these can'ts, they're not
Yeah.
just like side notes. They're actually like
They're a core part of the laws of physics.
a core part of the laws of physics. Okay. And this leads us to another really interesting concept, information.
Yeah, information.
How does information fit into all of this?
Well, normally we think of information as something abstract.
Right, separate from the physical world.
Exactly. But constructor theory says, no, no, no.
Okay.
Information is a physical concept, and it can be defined rigorously in terms of these counterfactuals.
Intriguing. How so?
Let's take a bit. The most basic unit of information.
Okay.
In constructor theory, a bit isn't just defined by its current state.
Like 0 or 1
Right, 0, 1. It's defined by the possibility of flipping it.
between those states.
Yeah, and the possibility of copying it.
Okay.
Those possibilities, those are counterfactual properties.
They define what a bit is.
not just what it's doing right now.
So it's about the potential for change,
Exactly.
not just the current state of things.
Yes. And Marletto takes this even further, actually.
Okay.
She uses this to propose a new definition of knowledge.
Wow. A new definition of knowledge. That's pretty bold.
It is bold, but it makes sense. She defines knowledge as a kind of information, a special kind. It has to be resilient.
What does that mean?
Resilient means it can stay embodied in physical systems
Okay.
and be transmitted reliably.
So it's not just fleeting thoughts or signals.
No, it's information that can actually, endure.
And be used to actually construct things.
Exactly.
So knowledge has this very specific meaning in constructor theory.
Yes.
It's tied to its ability to persist and be used to create.
Exactly. And this has implications for understanding,
Like what?
how complex structures arise, even life itself.
Wow. Okay. So it seems like constructor theory really challenges our basic assumptions about how the universe works.
It does. It really does.
So to put it simply, if traditional physics is about describing what is,
Right.
constructor theory is about understanding what can be.
That's a great way to put it. It's not about describing specific things that happen.
Right.
It's about identifying the fundamental constraints.
I know what's even possible in the first place.
Exactly.
And this has implications for, well, everything, it sounds like.
Absolutely. Information theory, the origin of life, you name it.
Well, I think we've covered a lot of ground already, but I'm really excited to dive deeper.
Let's do it.
Okay, so we've talked about how constructor theory is about what can be, not just what is.
Right. Possibilities, not just actualities.
But how does that actually change how we think about the laws of physics?
Well, one of the key ideas in constructor theory is that it wants to express all physical laws in terms of tasks.
Tasks. What does that even mean?
Well, a task is basically any transformation that could happen in the universe.
Okay.
Whether or not it actually does happen.
So like turning, I don't know, a 3 on a die to a 4.
Exactly. That's a task.
Okay, but things don't just transform themselves.
Right.
There has to be something that actually does the transforming.
Yeah, got it. And that's where constructors come in.
Constructors.
Yeah. A constructor is anything that can perform a task
Okay.
repeatedly and reliably without changing itself in the process.
So like a machine.
Yeah, like a machine or a process.
Okay, with you.
Think of a car factory. It takes raw materials and turns them into cars.
Right.
The factory itself doesn't change, but it keeps churning out cars.
So the factory is the constructor,
Exactly.
and the task is building a car.
You got it. But not all constructors are, created equal.
Right. Some are better than others.
Exactly. Some are more reliable, more precise.
And that's where the idea of accuracy comes in.
Right. Accuracy is key in constructor theory.
So an accurate constructor is one that can do its task really, really well.
Exactly. With high precision and reliability.
Like a skilled craftsperson versus, I don't know, someone who's just learning.
Exactly. The skilled craftsperson can create a much more intricate and precise result.
Makes sense.
And this idea of accuracy, it gets pushed pretty far in constructor theory.
Okay.
It's about the fundamental limits of how well a task can be performed.
So this is how we get to possible versus impossible tasks.
Yes.
A task is impossible if there's just no way to build a constructor that can do it.
At least not with arbitrarily high accuracy.
So like our perpetual motion machine.
Yeah. That's impossible because the laws of physics, they just won't allow it.
And what's interesting is that these impossibilities, they actually define what is possible.
Right. It's like they set the boundaries of what's possible in reality.
I see.
Yeah.
So we have all these possible tasks, some easy, some hard.
Yeah.
But the impossible ones, they're the ones that really define the landscape.
Exactly. And that's where knowledge comes back in.
Oh, right. Knowledge as a constructor.
Yes. Remember how we talked about knowledge as this special kind of information?
Yeah, resilient, able to copy itself.
Exactly. Like a recipe.
Like a recipe that can not only tell you how to make something, but also copy itself and be passed on.
Yeah, exactly.
So DNA.
Bingo. DNA is a perfect example.
It's a code that tells you how to build an organism.
And it gets copied so reliably.
Right. Fits perfectly with how constructor theory sees knowledge.
Yep. But of course, the big question is, where did that first recipe come from?
That first bit of knowledge.
Right. How does knowledge even get started in a universe that, doesn't seem to have any knowledge built in?
That's a great question.
And this is where constructor theory really shines, I think. It doesn't need any special starting conditions.
Okay.
Doesn't need any pre-existing blueprint.
No special, like, life-friendly laws.
Exactly. As long as the laws of physics allow for, digital information to exist.
Which they do.
Which they clearly do.
Yeah.
And as long as there's enough time and energy,
Okay.
then knowledge and ultimately life, it just becomes, well, almost inevitable.
So even if those first, like, replicators, those first bits of knowledge were, I don't know, really simple, really inaccurate, they could still, like, build up over time.
Exactly. It's like a process of trial and error.
Right, like evolution, but for knowledge itself.
Yeah, exactly. Imagine those early replicators, bumping into each other, combining, breaking apart.
All just following the basic laws of physics.
Right. And over huge amounts of time, some of them just by chance.
Yeah.
They'd stumble on more stable ways of copying themselves.
And those would be more likely to stick around.
Exactly. And they'd pass on their knowledge to the next generation.
So those first little bits of knowledge, they emerge from this chaotic early world.
Yeah. And once those seeds were planted, they could blossom into all the amazing diversity of life we see today.
Wow. That means life isn't just some, like, random fluke.
Right.
It's a natural outcome of how the universe works.
Exactly. It's built into the fabric of reality itself.
That's a pretty amazing thought.
It is, and it has some mind-blowing implications, too.
Okay, like what?
Well, for one thing, it means that life could potentially arise anywhere. The laws of physics are the same.
So not just here on Earth.
Right. Life might be common throughout the universe.
That's really exciting idea.
Yeah.
So constructor theory isn't just, rewriting the laws of physics.
Well, no, it's going even further.
It's changing how we think about life itself.
Yeah. It's giving us a whole new perspective on the biggest questions.
Okay. But constructor theory isn't all just theory, is it?
No, definitely not. It actually has some pretty practical applications, too.
Like what?
Well, one area where it's making a big impact is in quantum information.
Quantum information, so like quantum computers and stuff.
Exactly. Quantum computers and quantum communication networks.
Okay, that's cutting edge stuff.
It is. And it turns out that quantum information, it has some really strange properties.
Okay.
Properties that are, well, counterfactual.
Counterfactual, you mean like they're about what could happen, not just what does happen.
Exactly. And constructor theory can help us understand those properties.
And even use them, right?
Yeah. To build these new quantum technologies.
So constructor theory is not just about rethinking physics, it's also about giving us new tools to explore the quantum world.
Right. It's about pushing the boundaries of what's possible in both theory and practice.
Wow. It sounds like constructor theory is having a pretty big impact on pretty much everything.
It is. From computer science to our understanding of energy to even the origin of life itself.
It's pretty mind-blowing. But I think one of the most fascinating implications of all of this has to be what constructor theory has to say about the evolution of life.
Yeah, that's a big one.
And that's something we'll be exploring in the final part of our deep dive. So we've talked about how constructor theory changes how we think about physics, information, even knowledge itself.
Yeah, it's a pretty big shift.
But I think the most fascinating application of all this has got to be to the question of, well, the origin of life.
Yeah, that's a question that's captivated people for, well, basically forever.
Where did life come from? How did it all begin?
Exactly.
Yeah.
And traditionally, there's this kind of tension,
Okay.
between the apparent design we see in living things.
Right, they're so complex.
Yeah, incredibly complex.
And the laws of physics, which don't seem to have any, like, inherent design in them.
Exactly. The laws are just, well, they're just the laws.
Blind and indifferent.
Yeah, exactly. So
Yeah.
how do you get from those blind laws to something as intricate as a living cell?
Yeah, it's tough to reconcile.
It is. And natural selection, that explains how life adapts over time.
Right, survival of the fittest.
Exactly. But it doesn't tell us how life got started in the first place.
So there's this gap.
There's a big gap.
Right.
And that's where constructor theory comes in.
Okay, fill that gap for me.
Well, constructor theory gives us a way to understand how life, with all its complexity, could actually emerge from a universe governed by these simple, no-design laws.
So no need for, like, a divine creator or anything like that.
Exactly. In fact, Marletto, she uses this great phrase. She talks about the early stages of life as lengthy, highly inaccurate, non-purposive construction.
So a lot of trial and error.
Mm-hmm.
A lot of, like, random chance.
Pretty much. But how do you go from that primordial soup to, the order we see today?
Yeah, that's the million-dollar question.
It is. And the key is that idea of knowledge we were talking about earlier.
Right, knowledge is a constructor theory.
Yeah. Remember, it's not about conscious understanding.
Okay.
It's about a specific kind of information. Digital, resilient.
Capable of acting as a constructor itself.
Exactly.
Code like DNA.
Exactly. DNA is, well, it's a code.
It tells you how to build an organism.
And it gets copied so well, so accurate.
Perfect example of knowledge as constructor theory defines it.
It really is. But of course, the big question is...
Where did that first code come from?
Right.
Yeah.
How do you get knowledge in a universe that doesn't seem to start with any?
Yeah, that's a tough one.
It is. But here's the amazing thing about constructor theory. It doesn't need like a pre-existing blueprint or anything.
No special life-creating forces.
Nope. As long as the laws of physics allow for, digital information to exist,
Which they do.
which they clearly do, and as long as there's enough time
And energy.
yeah, then knowledge and ultimately life,
It just kind of happens.
it becomes, well, almost inevitable.
So even if those first replicators were like really basic, really prone to errors, they could still, gradually improve, get better at copying themselves.
Exactly. Imagine them, bumping around, sometimes combining, sometimes breaking apart.
All just following those basic laws of physics.
Exactly. And over vast, vast amounts of time, some of them just by pure chance.
Okay.
They would stumble on better ways to copy themselves.
And those would have an advantage.
Yeah, a huge advantage. They'd pass on their knowledge to the next generation.
So those first little bits of knowledge, they emerged from this chaotic early universe.
Exactly.
Yeah.
And from those humble beginnings, you get everything. All the diversity of life we see today.
So life isn't some like cosmic accident.
Right.
It's a natural consequence of the laws of physics.
It's built into the fabric of reality itself.
Wow. That's a pretty profound thought.
Yeah.
So constructor theory, it's not just about physics.
Yeah.
It's about life, about the universe, about everything.
It really is. It gives us a new way to see the grand story of it all.
From the Big Bang to us.
Exactly. And the crazy thing is, constructor theory is still so young.
There's so much more to explore.
No, absolutely. But it's already given us a whole new way to think about the universe and our place in it.
It reminds us that the pursuit of knowledge, it's a journey, it's an adventure.
And it never really ends.
So to everyone listening, keep asking those big questions.
Yeah, keep exploring.
Keep diving deeper. Who knows what amazing things we'll discover.